Welcome back. We're in section 612. We're going to talk about using a graph to find an inverse. So now we can write an equation to represent this table. So to find the equation, we need to find the slope. So the slope, y sub 2 minus y sub 1, x sub 2 minus x sub 1. So you can pick any 2 points. I'm just going to pick those first 2 points. So for our y's, 7 minus negative 5 over 3 minus 1. 7 minus negative 5 is 12. 3 minus 1 is 2, so our slope is 6. And now we need to find the y-intercept. You can use that point slope form. Y minus y1 equals m x minus x sub 1. So I'm going to pick a point. I'm going to pick the point 3, 7. So y minus 7 equals the slope, which is 6 times x minus 3. Y minus 7 equals, distribute the 6, 6x minus 18, add 7 to both sides, so y equals 6x minus 11. That's the equation for that table. Now we can make a table for the inverse by switching the x and y. So what we're doing for the inverse is we switch the inputs and outputs. So we had our values for y, we're going to put our values for x. So here, negative 5, our x would be 1, 7, 3, 19, 5, 31, 7. And that's a table of values for the inverse. We switched the x and the y values. Now we can write an equation for this new table, So we'd have to find the slope first. M equals y2 minus y1, x2 minus x1. And it doesn't matter which points we pick. I'm going to pick these two in the middle just because I feel like it. 5 minus 3, 19 minus 7. So the slope is going to be 2 over 12. So the slope is 1/6. Using that point slope form, y minus y1 equals m x minus x1. So using the point 7, 3. So y minus 3 equals 1/6 x minus 7. It doesn't matter which point you pick. You'll get the same answer in the end. Y minus 3 equals, now we distribute the 1/6. We get 1/6 x minus 7/6. Add 3 to both sides. So y equals 1/6 x minus, now it's 7/6, and that's a 3 over 1. So we multiply by 6 over 6, we get plus 18 over 6 to get that common denominator. So y equals 1/6 x plus 7, negative 7 plus 18 is 11 over 6. And there is the equation for the inverse. Now to graph the inverse, remember we're switching the inputs and outputs. For y equals 1/2 x plus 3. The slope is 1/2 and the y-intercept is 3. So here's our point 0, 3. And then we go up 1 and over 2. We can also go down 1 and to the left 2. And there, And there's our graph of y equals 1/2 x plus 3. Now, we could graph the inverse by actually just using a table. So here's what we could do. For y equals 1/2 x plus 3, if you look at a couple of the points, we have 0, 3. We have 2, 4. We have 4, 5. We have negative 2, 2. We have negative 4, 1. We have negative 6, 0. So for the inverse, we can actually just switch the x's and y's. So we'd have 3, 0, 4, 2, 5, 4, 2, negative 2, 1, negative 4, 0, 6. Oh, sorry. That's a 0, negative 6, excuse me. 0, negative 6, 1, negative 4, 2, negative 2, 5, 4, 4, 2, 3, 0. Here would be our inverse. There's our inverse. So that's one way to find it, is you can just plot the opposite values. Now, we could also find it algebraically. So we had y equals 1/2 x plus 3. We're finding the inverse. So x equals 1/2 y plus 3. Subtract 3 from both sides. X minus 3 equals 1/2 y. To get rid of the fraction, multiply everything by 2. 2x minus 6 equals y. So y equals 2x minus 6. So the slope would be 2, and the y-intercept is at 0, 6. Oops, sorry, 0, negative 6. And you can see 0, negative 6, and then we're just going up 2 over 1. You see how that matches up to our graph? Those are inverses. And another thing to see with these is inverses are the reflections of each other along the line y equals x. If you were to hold a mirror along this diagonal line y equals x, you'll see that the graphs match up. And that's another property of inverses. Let's go to the next page. The horizontal line test. Now, we can determine if a graph is a function. Using the vertical line test. So what that means, if I have a graph like this, if I draw a vertical line, it's never going to intersect more than once. So it would be a function. Now, if I had a graph that looked like this, if I draw a vertical line, it would intersect twice. That would not be a function. Now, the horizontal line test isn't to determine if that graph is a function. It's to determine if the inverse of a graph is a function. Here, for the horizontal line test, if I have a graph like this, if I draw horizontal lines, it's never going to intersect more than once. So the inverse is a function. If I have a graph that looks like this, if I draw a horizontal line, you can see it intersects twice. That would say that the inverse is not a function. So what we're going to do is we're going to sketch y equals x squared plus 4. So the vertex is at 0, 4, and a is 1. So all we have to do is go over 0, 4, and a is 1. So I talked about this earlier. If our perfect squares, we go 0, 1, 4, 9, 16. What we're doing is we're adding 1, adding 3, adding 5, adding 7. So to find the next points, we just go up 1 over 1. From that, we go up 3 over 1 in both directions. And then you'd go up 5 and over 1 in both directions. Here's our graph. Now, that graph is a function. But this question is saying, is the inverse a function? And no, it's not. No, the inverse is not a function. It fails the horizontal line test. It fails the horizontal line test. If I draw a horizontal line, it's going to intersect at more than 1 point. And for example, right there, it fails right there, that horizontal line test. Now, the reason it is, if I were to draw the inverse of this, you see we're at the point 0,4. We'd have the point 4,0. We have the point 1,5. We'd have 5,1, negative 5,1. And this one, and this one. This is what the inverse would look like. And you see, that's the inverse. The inverse fails that vertical line test. And we can use the horizontal line test without even looking at the inverse to make that decision. Let's do one more. Find the inverse of y equals x over 2 squared algebraically. So the inverse. So if we have y equals x over 2 squared, x equals y over 2 squared. So we take the square root of both sides. And when we do that, we get two solutions, positive and negative. And then you multiply both sides by 2. So y equals plus or minus 2 times the square root of x. Okay, so what we're going to do is we're going to graph the first one, y equals x over 2 squared. And I'm just going to use the calculator, 0, 0, 2, 1, negative 2, 1. We've got, we've got 4, 4, negative 4, 4. And then 6 and 9, negative 6 and 9. And I just use my calculator. There's y equals x over 2 squared. Now I can tell right away from the horizontal line test, the inverse is not a function. Now when we graph the inverse, what you're going to get is you can switch the x and the y's if you really want to do it easier. 0, 0, 1, 2, 1, negative 2, 4, 4, 4, negative 4, 9, 6, 9, negative 6. So here, this green graph represents the inverse. And you can see the inverse fails the horizontal line test. It fails the vertical line test. So the inverse is not a function. The inverse is not a function. All right, that is it for this part. I'll see you again in part 2. Thank you and have a nice day.